What's up, everybody? Joe here, and continuing on with our ICND1 blueprint analysis, we're looking at the IP routing technologies today. So starting out in section 4.1, describe basic routing concepts, pretty much exactly what it says here. So 4.1a, packet forwarding, and 4.1b, router lookup process, are kind of very similar in nature. Basically, this is saying understand how a router actually forwards packets. What type of information does a router look at in order to make a routing decision? So basically what this boils down to, guys, is, at least for purposes of ICND1, destination IP address. Okay? When a router gets a packet, we're going to look at the destination IP address. We're going to then match that destination IP address as best we can with our routing table, and we're going to want to understand that process. So packet comes in, check the destination IP, do a routing table lookup, and then send the packet out the correct outgoing interface. Process switching, fast switching, and Ceph switching. On your Cisco routers, there's various different ways we can route or technically switch packets in hardware. Okay, and this has evolved over the years. So originally we had process switching, which is basically a very CPU intensive way to get the packets through the router because the CPU is doing all the work. Then we moved into fast switching, which got the hardware involved, and we've improved on that with Ceph or Cisco Express Forwarding. So I would say have a high level knowledge of what those three processes are as far as routing. Moving into 4.2 here, this is what I like to call no excuse to miss these points. Again, just like we saw with switching, they're giving you basically a list of commands that you need to know how to do on a Cisco router. So remember, on a blueprint, whenever it says configure and verify anything, what this means is that you need to know how to do this on an actual real piece of equipment. So I would just go through the list and make sure that you have experience running every single one of these commands. Practice, practice, practice. Just do it over and over again until you've got mastery over it. So things like setting the host name, setting up a local username and password, setting your enable secret, setting up telnet and console passwords, so on and so forth here. How do you set a login banner, message of the day? And these are all very fundamental commands that you should know. So really, that's pretty straightforward, no mystery there. Let's move on to 4.3, configure and verify operation status of an Ethernet interface. Okay, so again, configure and verify, which tells us we need to know how to actually do it and what are the show commands to verify that what we think we did is actually what we did. Okay, so this is going to be things like going into global configuration mode, interface configuration mode, and doing things like putting an IP address and a mask on an interface, doing a no shutdown command, maybe putting a description on an interface, setting the speed and duplex on an Ethernet interface. And then to verify, I would look at things like show interface, show IP interface, show IP interface brief, things of that nature. 4.4, verify router config and network connectivity using these tools. So basically it's giving you a list of tools that we need to know how to use. Again, pretty straightforward. Ping, traceroute, telnet, secure shell, and show CDP neighbors are all things we should be able to do from a Windows box or a Cisco iOS router. So you're going to want to make sure you have a good knowledge of that. As far as telnet and SSH, I would say you should also know how to set up routers to be telnet and SSH servers. So in other words, it's not just knowing how to telnet and SSH from a router to another box, but how do you telnet and SSH into the actual router so that you can control it remotely. So 4.5, configure and verify routing configuration for a static or default route. Very straightforward here. So basically we're saying you need to know how to configure a static route at the command line. That's going to be from global config mode, the IP route command, right? So IP route, then the network and the mask of your route, and then the next hop IP or outgoing interface. Configuring a static default route, very similar. That's our IP route 0000. command. So we're going to want to make sure we have plenty of practice doing that. Verifying that is going to come down to basically a show IP route. Different methods of routing and routing protocols in 4.6. Understanding the difference between static and dynamic routing. So static is going to be where we, do what we talked about in the last section here, where we're actually writing static routes to particular networks. Dynamic routing is going to involve, that's where we get involved with different routing protocols, like RIP, OSPF, EIGRP, so on and so forth. And then moving on here to link state versus distance vector. This is basically describing the different kinds of routing protocols we have, right? So for example, distance vector routing protocols would be like RIP and EIGRP, whereas link state routing protocols are going to be OSPF and IS to IS. They fundamentally work a little bit different. So basically a distance vector routing protocol you might hear called routing by rumor. In other words, we only know the routing information that was told to us from our neighbor, but we don't have a big picture overview of the entire network. Link state routing protocols like OSPF operate differently than that. So they actually have a complete picture of the entire network, and then they can build the routing table based on the best path that it calculates from having all that information. So you want to understand the fundamental difference between link state and distance vector. Next hop is simply saying, when we're setting up routing, whether it be static routing or dynamic routing, the next hop is going to be the router we send the packet to next when we do that routing lookup. Of course, understanding what the routing table is, that's our show IP route. How do you decipher it? You're going to probably want to look at things like understanding the administrative distance in the routing table and the different routing metrics, the next hop, and essentially how to read that table. Passive interfaces are going to be interfaces in a routing protocol that we specify do not send out updates. Okay, so we might want to advertise a particular network, but we don't want to run the routing protocol on that particular interface. Moving on, basic OSPF. So no surprise here, we need to know how to configure single area OSPF. So basically it's saying know how to do single area OSPF for IPv4, and for IPv6, OSPF v3 is only for IPv6. So you're going to need to know both, know how to manually set the router ID, and again, passive interface. The bad news with OSPF is it's a very complex protocol. The good news is at the ICND1 level, you can pretty much do everything you need to do with maybe 3 or 4 commands. So not very overly complex. Finally, we've got inner VLAN routing in 4.8 here. So basically this is going to come down to a few things. Router on a stick. So you're going to need to know how to configure sub-interfaces on the router, which basically comes down to creating the sub-interface, setting the VLAN encapsulation, and then setting up the switch port that it connects to as a trunk, so that you can do routing between your different VLANs. And then SVI interfaces, we see here in the last topic, SVI interfaces are switched virtual interfaces. These are routed interfaces off of a layer 3 switch. So for example, on a switch, you might have interface VLAN 10, interface VLAN 20, and you're going to put an IP address on each of those so that they can route between each other. That's switch virtual interfaces. That's about it here for the routing section of the ICND1 blueprint. Thanks everybody for watching. If you are enjoying the videos, subscribe to the channel here on YouTube. You can also check out the blog at AskDarinoNetworks.com or follow me on Twitter at JSDarino. Thanks everybody for watching, and I'll talk to you soon.